Howdy. We're going to be taking a look at page 155, number 67. And in this problem, they give us a formula for the period of oscillation of a simple pendulum. And they also tell us that if the pendulum is made out of metal, its length will vary with temperature, either increasing or decreasing at a rate that is roughly proportional to L. And then they translate that very statement into math. dU du, is equal to K times L. This language, by the way, is we're going to see very commonly, so let's see how the language relates to the math that's written. The rate of change of L with respect to U. That's this guy right here. The rate of change of L with respect to U. And is proportional to means equals a constant times, and then is proportional to L would mean is a constant times L. So we have this information, dL du is equal to K times L. The rate of change of L with respect to U is proportional to L. And now they ask us to show that the rate of change of the period with respect to temperature we're supposed to show that this rate of change with respect to the period with respect to temperature is equal to K times period over 2. Well, to begin with, we need to take this English and translate it into math. We're looking at a rate of change, that is a derivative of the period, which is T, with respect to temperature, which they use U for. In other words, we're supposed to show that dt du is equal to kt over 2. Well, where to begin? Where to begin? Since we are looking to show that dt du is equal to kt over 2, we should probably start by finding the derivative of t with respect to u. So here we go. T equals 2 pi root L over G. And therefore, when we take the derivative with respect to u on both sides, give ourselves a little more room to work with. Then on the left-hand side, we get dt du. On the right-hand side, constant multiple rule looks good here. And if we do a little bit of algebra, then we can see that root L over G is the same as root L divided by root G. And root G is just a constant. G, the acceleration due to gravity, the square root of that is going to be somewhere around 3.1. So that I can once again use constant multiple rule to pull root G to the outside, and I'm left with simply d du of root L. And that's not too bad. Using the chain rule, it's going to be the derivative with respect to L times dL du. And all of this is equal to dt du. Well, according to the problem, I'm supposed to show that this is equal to kt over 2. That's my goal. So it must be the case that all of this somehow collapses to kt over 2. Let's see if we can see how. Substitution is clearly our way to go here. Do we have any additional information? Yes, we do. We know that dl du is equal to k times l. So let's substitute that right here. So we have 2 pi over root g times 1 over 2 root l times kl. Now let's see, what algebra can we do here? Well, we have L divided by root L. That's L to the first divided by L to the 1/2. Subtract exponents and get root L left over. We have a factor of k. We have factors of 2 that cancel out. We have a factor of pi. And we have a factor of root g. How does this look in comparison to what we're supposed to get? Well, I see the factor of k right here, but I don't see a t just yet. And I look back and I say, oh, that's right. T is equal to 2 pi times root L over G. And if I look, I can see I have a pi, I have a root L, and I have a root G sitting right there. I have all this. So it makes sense then to do a little bit of solving and say that T over 2 is equal to pi times root L over G, so that I can replace all of this with T over 2. And lo and behold,